All respected teachers and my dear juniors and classmates, I am Subhranshu. Today going to present the topic Supernova explosion. These are my contents. What is supernova? Its early discoveries, formation of supernova, classification of supernova, supernova explosion, result of the supernova explosion, supernova in light, and future supernova tendencies. What is supernova? A supernova is a powerful and luminous explosion of massive stars, which is occurs the last turbulent stages of a star. Supernova can briefly outshine the entire galaxies and radiate more energy than our sun within a entire lifetime. They are also the primary source of heavy elements in the universe, also in the Earth. The word supernova was first coined by Walter Wade and Louis Zwicky in 1931. According to NASA, supernova are the largest explosions that takes place in the space. Early discoveries of supernova. The earliest recorded supernova is SB9, which was recorded by the people of Indian subcontinent in Kashmir. Later, SN185 supernova was viewed by Chinese astronomers in 185 AD. The brightest supernova was SN1006, which has occurred in 2006 AD in constellation of Rupert star. The Car Nebula, the most famous nebula this is, was spotted by Chinese and Korean astronomers. The most recent naked supernova was supernova 1987, which was the explosion of blue supergiant star, a satellite of Milky Way galaxy. These are the figures of some supernova. This is the Car Nebula, the most famous nebula, and the most recent naked nebula is the supernova 1987, the last one, and the brightest supernova is the SN186. Then come to the topic formation of supernova. A star with huge masses, at least more than 1.5 times of solar mass, becomes red supergiant and then becomes supernova. The conversion of a star into supernova totally depends upon mass of stars. Most of the supernova are triggered by one of the two basic mechanisms. These are sudden reignition of nuclear fission in a white dwarf or the sudden gravitational collapse of a massive gas core. In reignition of white dwarf, the object's temperature is raised enough to trigger runaway nuclear fission, completely disrupting of the star. In massive stars sudden implosion, the core of the massive star will undergo sudden collapse. One will be unable to produce sufficient energy from fusion to counteract the star's own gravity, which happens once the star starts to fusing ion. Then classification of supernova. Classification of supernova on the basis of amount of hydrogen lines in their envelopes. They are type I and type second I. This is the figure of type A, type second I supernova. Then type I supernova. Type I supernova contain no hydrogen lines in their envelopes. They are further subdivided into three types on the basis of their spectra. That is type 1A, type 1B, and type 1C. Type 1A shows strong silicon lines in their envelope, while type 1B shows helium lines, and type IC lacking all of them. Then type second is supernova. Type second is supernova with clean lines of hydrogen in their spectra. They are also subdivided on basis of their spectra into two types. One is type 2N and another is type 2B. Type 2N is, has broad emission lines in their envelope, which shows that expansion of velocities of many thousands of kilometers per second. And type B is in the type B supernova. They saw hydrogen lines, but over a period of weeks to months, they dominated by lines of helium. Then come to the topic supernova explosion. Two types of supernova explosion occurs, that is thermal runaway and next one is core collapse. Only type IA, type 1A undergoes thermal runaway explosion and all others undergo core collapse. In thermal runaway mechanism, a carbon oxygen white dwarf accreted enough matter to reach the cosmic limit, which is about 1.44 solar mass. Then it would no longer be able to support the bulk of its mass through electron degeneracy pressure and start to collapse. The collapsing of white dwarf will typically form a neutron star. In this case, only fraction of the star's mass will be ejected during the collapse. Within a few seconds of collapse process, the substantial fraction of the matter in the white dwarf undergoes nuclear fusion, releasing enough energy 1 to 2 10 to the power 44 in unit of joule to unbind the star in a supernova. The model for the formation of this category supernova is closed binary star system. The larger of these two stars is fast to evolve up and main sequence, and it expands to form the red giant. And then the red giant stars sets most of this envelope, losing mass until it can go longer continued nuclear fusion. At this point, it becomes a white dwarf star composed of carbon and oxygen. Eventually, the second star also evolves to become a red giant. Matter from the giant is accreted by the white dwarf, causing the latter to increase in mass. Then the core collapse mechanism. This is the classic explosion. It occurs in a progenitor in a very massive star, which is at more than 8 solar mass. Until this stage of evolution, the star shown by means of the nuclear energy released at its core in the process of squeezing and heating lighter elements such as hydrogen helium into successively heavier elements. That is in the process of fusion. In this process, after hydrogen helium, other elements carbon, oxygen, and silicon up to iron form. Forming elements heavier than iron absorbs energy rather than producing energy. Since there is no energy available, the iron core is built up at the center of heavier stars. When the iron core becomes too massive, its ability to support itself by means of the outer explosive thrust of internal fusion reactions fails to counteract the pull of its own gravity, and then it collapses. The core consists of almost entirely of neutrons, which are compressed in a volume of 20 kilometers. So an object is called neutron star. This is the layering of the core collapse mechanism. Outward to inward. Result of supernova explosion. The exploded star will partially collapse into a black hole or a neutron star, and the rest of the mass will get converted into energy or will be blown away. This blown away material is called supernova remnant. If the exploded star was very massive, some of the said material will get spun up around the resultant black hole or the neutron star and then get sent out through a speed of close to the speed of light. Because the material is moving so fast, it can emit photons at very high gamma ray energies. This is called gamma ray burst. Supernova and life. Uh, Without supernova, there would be no life on Earth because this is because many of the chemical elements were made in supernova explosions. They are heavy elements. Heavy elements are needed to make living things or the particles which are in the living organisms. The supernova is the only natural way to produce heavy elements. Heavy elements need very high temperature and pressure to form. In a massive supernova explosion, the temperature and pressure are so high that heavy elements can be made. This is called the supernova nucleosynthesis. The explosion is very big and many kind of dangerous radiations are formed, but we don't have to worry because there is no such big stars near the Earth. These are future supernova candidates. Future supernova candidates are the supernova or the stars we are going to supernova explode, which are listed by the astronomers. These are some supernova candidates: IK Pegasi, Spica, Antares, and Ryder. Then the summary: supernova is the powerful explosion of massive stars based on the presence of hydrogen lines in supernova envelope. It's classified into two types, that is type 1 and type 2. Two types of fundamental supernova explosion occur. They are thermal runaway and core collapse. In thermal runaway, carbon oxygen white gas accreted matter from surrounding when its mass exceeds Chandrasekhar limit, it explodes. In core collapse mechanism, when the star starts producing iron at core by nuclear fusion, it absorbs energy rather than producing, so it collapses. Heavy elements are formed in supernova explosion, which is the only natural way which is essential for life on Earth.